Hello guys, Fro here, welcome to the channel. I was having a conversation with one of my students recently and the question came up of, is Python a very slow programming language? So in today's video, we're going to go to the whiteboard and we're going to answer two questions. Number one, is Python really a slow programming language? And if so, number two, why? So let's go into the whiteboard and we can start with our very first question for today. Why is Python slow? Now, this assumes that Python is a slow programming language. Now, before we go in, I'll give you a little bit of an analogy here, which I think hopefully will hit the point home. Consider you have an individual, and this individual has a goal of traveling. They want to travel abroad. They want to go to, say, Europe, and maybe this individual is in the US. And the goal for this individual is to go over to, say, Europe. And let's just take a country here, say Germany. And the individual has to go to Germany. Now, to go over there, there are two things. If you are from the US and you're going over to Germany, you don't speak German, you're going to need to communicate with the German people. You're going to have to speak their language. If you don't speak their language, you cannot communicate. So what are the two things you can do? The very first thing you can do is to say, hey, I would take my speech. Let's say you are going over to Germany to give a speech. You can say, hey, I'm going to take my speech. I'm going to hire a translator to translate it from my language that I speak, which would be, let's say, English, and they're going to translate that speech to you, and they might translate that to you to German. So this speech is translated to German. Now you have that translated speech, and all you have to do is you take that speech, you go over to Germany, and voila, you have your speech ready for you. All right. And so this speech has been pre-translated before you go over to Germany. That's one way to do it. Now, there are a couple of things that we have to pay attention to here. Number one, which is this aspect of translating the speech from English to German happens once. Now, it might take time. You might have to figure out how to do the translation, to look at the syntax. It might take time, but you do it once. And once you do it and you go over to Germany here on the right side, all you have to do is keep reusing this translated speech. So if you want to give it to one person, you give them a speech. Two people, you give them a speech. Three people, you give them a speech, all the way to n number of people. You've really translated your speech, and now all you have to do is distribute the speech out, and you could be very fast that way. All right, take this situation. So this is situation number one. Now take the situation of one other person who wants to go over to Europe in a very similar situation, but they say to themselves, hey, I'm not going to play all these games of translating my speech. I'm more agile and I can just make it work. And so here's what this person does. Person number two says to themselves, hey, you know what I'm going to do? I am going to hire a translator to come with me. So this person is going over to Europe, to Germany here. All right. And so what they do is they go out and they say, hey, I am going to hire a translator and I'm going to bring this translator with me over to Germany. Now, what would this translator do? This translator would be responsible for listening to everything I say and they translate it to German. So if I say, if I make one sentence, this translator is going to translate it. I make the next sentence, they take it and translate it. I make the third sentence, they take that sentence and translate it. I make the fourth sentence and they keep doing that translation all the way to end sentences. So every communication I have, I might be going to the library. I might just be walking the streets of Germany and having a conversation with the amazing people of Germany. Now, every conversation I have, they have to go in and do that translation. Now, the question intuitively is, which of these approaches is going to be faster? Now, to answer that question, there's going to be a little bit of nuance, but just intuitively, which of these approaches will be faster? Someone who takes the time in this step above to pre-translate what they need, and they just give it to whoever needs it over and over. They can just give it to that person. Or the person who goes over and every statement they make has to be understood and translated, has to be understood and translated, has to be understood and translated. Now, you can make the argument that this one might be faster and this might be a little bit slow. because number one, you're walking around with a translator. Number two, they have to listen to you, understand what you say, translate it, and then listen back to you, understand what you say, translate it, and then listen to you, understand what you say, and then translate it. Now, this gives us the intuitive base of the comment, why is Python slow? Now, let's go away from our regular languages and talk about programming languages. And I think hopefully this intuition will give us a good understanding of why you might say programming languages are slow. Now, in the world of programming, there are really two camps to think about. In the world of programming, two camps. The very first camp would be the camp of what is called compiled languages. And your second camp would be the camp of interpreted languages. And I'm sure you can start seeing the analogies here, or how this is comparable to the example we gave before. Now, what are your compiled languages? If you think of languages like C, C++, maybe Java, Haskell, you name it. These languages typically, let's put this in a box, will be your compiled languages. And what does compiled language means? Well, it essentially means the very first example we had here on the screen, it essentially is the situation where somebody takes what they want to say, they translate all of that. That way they can have a translated copy of what they have to say, and now all they have to do is just give out the translated copy. So the translation piece might be taking a long time, but once it's been translated, just hand out your translated copy. So in the world of compiled languages, essentially it means that, let's actually draw this out. So if you have a programmer here who is going out and writing code, you're writing your source code. What happens in the world of compiled languages? That source code is taken, it goes through a compiler, right? So here it goes through a compiler, and this compiler gives you machine code, and then this machine code gets executed by the machine. This will be the flow of your compiled languages. So number one, whenever you write your source code, so this is source, whenever you write your source code in Java, the compiler takes that, it understands the syntax, the formatting, the lexical analysis, and a lot of things happens within that to take that and pass it into an output called the machine code. The machine code is then, which is compiled, is then what gets executed by the machine. Now, I'm just kind of saying this in general. There are some more steps in there, especially for Java and some of the languages. But the takeaway from this is a compilation happens. Now, how is this different from the interpreted languages? So let's look at the interpreted languages. For the interpreted languages, and we're going to use a different color for this interpreted languages. Let's go with green for the interpreted languages. Now, for the interpreted languages, you might hear of, let's say, JavaScript. And yes, Python would be in your family of interpreted languages. There are a lot of languages that will fall under the family of interpreted languages, but the ones that two people or most people are familiar with would be JavaScript and Python. Now, what is the flow for the interpreted languages? Going back to our example of somebody traveling to Germany, we're going to be looking at this second flow here, where instead of that person taking what they have to say and pre-compiling that and translating it and then going out and then giving it to everybody, what they do is they hire an interpreter, and that's where interpretation comes from. Hopefully it all makes sense now. So they go out, they hire an interpreter, and they walk around with that interpreter. So let's go back here with Python. So what does the flow of Python looks like? So somewhere here you have somebody who is going to write your source code, and this source code will be in a .py file. Typically it's in a .py file. Now, once that source code has been written, which is human readable, you and I can read the source code. Now, once that source code has been written and you want to execute this, the flow is a little bit different, but there are some catches for Python, which you want to call out here, okay? Because this will surprise some people, but there are some catches. So let's really unpack this a little bit more. So what would that look like? In general, what we would say is Python is an interpreted language. And in general, what it would mean is when you write it, you send it to Python, there is some form of an interpreter here, which takes your source code in Python that you and I can understand when you're writing in Python syntax and declaring your variables, declaring your functions, and performing some action. Now, it goes through this quote-unquote interpreter. The interpreter then goes out and then it brings all the support packages. So you can really skip all of this, but just to include that in there, it brings all the supporting packages to make your code run. Now, once your interpreter takes all of that, it's gonna spit out something that can be executed, right? Something that can be executed. But what is that something? And this is key, right? Because your interpreter will take what you're saying, it does something, and it spits it out. But Python goes a little bit further. So let's go a little bit further into what actually happens underneath the scene. So here again, we're gonna start with a source code, which is .py, which is what you write. When you write Python, you open your code, your editor, you write a .py file. A couple of things happens. So let's draw a bigger box for this interpreter to see what happens. The very first step, and I know folks will be surprised by this, is compilation. There is still some compilation. There's still a compiler. A compiler takes that raw source code that you write in English and is gonna translate that and come up with something called the byte code. The byte code. And it does this in real time. It takes that, it's understanding the lexical analysis, is doing the syntax analysis, is doing a lot of things to compile that and give you something, this output called the byte code. Now, this byte code, it's what gets sent into the machine. So in this case, we'll call this a PVM, which is essentially the virtual machine to run, the Python virtual machine to run. All right. Now the Python virtual machine executes that and you have output. You have your output. And this step happens every time you execute. So unlike a language that would compile everything before it starts executing, in Python it's taking what you write, it goes through this compiler, it creates this bytecode, the bytecode gets sent into the PVM and that gets executed. And every time you're doing this has to happen. Every time you're doing this has to happen. And in here, if there are packages and modules that it needs to use, it gets those and it uses that. And if even go further into this, there's even one step that we can go into this to really explain why Python could be really looked at as being a slow language. Number one, here again, we're going to start with our source code. Here, as we saw, the source code gets turned into bytecode, right? In Python, you always have to go through the bytecode, Python bytecode. Now, what takes this source code to make that into bytecode? Here we have a compiler, right? The compiler takes the source code and it makes it into a bytecode. Now, once we have, let's go back. Now, once we have the bytecode, what happens after that? You can say, hey, the bytecode goes into the PVM and it's executed, but there's even more to it than that. Let's just do an outline here of a simple box. The bytecode goes into, it has to be converted to assembly because machines don't just understand bytecode. They'll have to still go further a little bit. If this is a little bit more advanced, you can skip through these concepts, but just understand that in here there is some form of assembly code that needs to be generated. The assembly code gets turned into machine code, and that machine code is actually what gets executed. Okay, the machine code is what gets executed. And all of these steps needs to happen. So in a certain extent, we can, for the sake of the conversation, we can draw a line around this box of what happens in here. We can draw a line around that box and what happens in there. And what we're gonna do is we're gonna call this interpreter. Again, when we say Python is an interpreted language, a lot of things happens underneath the scenes, and this happens every time you run a Python code. For the most part, for the most part. I know there are situations where you might compile code into a file which is, instead of .py, you get it into .pyc, which is a Python compile code. But that's a little bit advanced. Just for the everyday parlance, let's just assume that Python is an interpreted language, and every time you have to execute Python code, it gets interpreted like this. Now, how many steps are in here for this to happen before your code can run? Here we're seeing source code to bytecode, 1, bytecode to, say, assembly, 2, assembly to machine code, 3, machine to execution, 4. I mean, you can put in a lot of steps in there for that to get executed. I'm oversimplifying this. Yes, I know I'm oversimplifying this, but this kind of gives you the steps in there for that code to finally be executed. Compare this to a situation where, like we saw earlier, for this for the compiled code, where all you have to do in this case is, 1, take your code, compile it into machine code. So we have 1 step, compile it to machine code. Now, once this code has been compiled, you can execute n number of times, and you don't have to keep going back and recompiling that code. You can just take it and just execute n number of times. Whereas with interpreted code, you have to go through all the steps of the interpretation before that code gets executed. So there you have it. Someone, again, one of my students asked, I've heard Python is a slow programming language. Is that true? Now, despite all of these statements being made, it still would be a little bit disingenuous to make the comment that Python is a slow programming language, because slowness is something very relative. It all depends on what you're trying to do. Now, Python is a very capable language. That's why tons and tons of people use it for machine learning, for data science, for application development, or just everyday scripting and automation. You would see Python. If you stack up programming languages, Python will be up there in the top 5, solidly in the top 5. I think SQL is number 1, Python is number 2, and maybe Java or something like that. But that list kind of changes, but Python is definitely up there. And when you're talking about working with data and data science, Python is hands up number 1 up there. Well, second to SQL, they're a little bit different, but if you talk about the utility of Python, Python is definitely up there when it comes to the usefulness. Now, so making the comment, Python is a very slow programming language, you have to think about the context. In what context are you talking about? Give you an example, just to give you an example. The everyday person driving down the road might look at the car, some sports car, and say, hey, this sports car I went to the dealership and bought is extremely fast. In that context, sure, that sports car might be extremely fast. But if you were talking to a NASCAR driver, the fastest sports car you'll get from your dealership down the road is a slow car for them. So context does matter when we make the statement of why is Python slow. Context does matter. What are you trying to use Python for? Now, there are applications where you really need the throughput of latency. You can't afford your application to be compiling and doing all this interpretation all the time. Latency is key. We're talking about high performance gaming, maybe image processing, low latency types of application. You definitely want a language that's very performant. In that case, people use a lot of C for programming that. Now, if you are the everyday person like you and me, and we're doing some machine learning, we're training a model, we have to wait a few minutes for our model to get trained, the benefits of you having this rich ecosystem of Python is going to outweigh whatever sub-second performance you can get in that case. So for you, Python will be a perfectly good language to use. As a matter of fact, it's the best language to use in that case. So hearing Python is slow doesn't necessarily discredit Python in any way. But hopefully in this video, if that perception comes up that Python is slow, now you know why that perception might exist, or at least one of the reasons why there is more, right? And you might just not be writing your code correctly, and so you're slow, you're not using the right packages. There are a lot of things in terms of Python has dynamic It doesn't have type checking, and so a lot of those things are dynamic once the code is executed. But those are technical stuff, right? We're just gonna come up here to the higher level and just understand this. Why Python is slow? Say it's because it's an interpreted language. A lot of interpreted languages will be slower than your compiled languages. Now, despite making that statement that Python is slow because it's in the interpreted family of languages, it's still worth understanding what is your use case. Why are you trying to use Python? And if you understand your use case, then Python might be the perfect language for you, regardless of whether it's slow. If you're going to be a NASCAR driver with your programming language, I mean, if you're going to do some high performance application development, then yes, look beyond Python. But for the everyday use cases, Python might just be good enough.